Turn off the lights. Don't sleep. Okay. Okay, this is a computer program, SAP. I'm a little bit doubtful that when I will upload this video, you might not be able to see like file or at the top, file, edit, view, draw, which you can see by your eye right now. But don't worry, the next time I will install a program. Why I did not install? Because it makes the computer very heavier. It is like a recorder inside the computer which will record the video of the screen, you know. So next time I will try to take laptop from maybe the new one from one of our doctor, maybe Dr. Faisal. So and I will install the SAP and also that program. So in that case, maybe we don't need these videos from the camera. We will just use the computer video and I will upload it. You understand what I'm saying?
Yes.
But this is just today because I'm going to expose you with the I'm sorry, that was a cleaner and he was making a lot of noise. Okay, so you know when I teach this SAP or any computer program like ETAP, SAP, they are all linked together. Even the AutoCAD is linked together with these computer programs. Like you can work in AutoCAD, you can transfer your plans from AutoCAD to SAP, ETAPs or SAP. What is SAP and ETAPs? ETAPs is extended three-dimensional analysis of building systems. That is a specialized program for buildings. And SAP, that is for the foundations. SAP is for the foundations. Like you know about the mat foundations, you know about the strip foundations. So if you have to design the foundation, we use SAP. SAP cannot design foundation. SAP cannot design slab. SAP can design beam, column, and for the slabs, it will give you the forces, the moments and stresses. In all this procedure, you know the most difficult thing is to get the forces. Once you have BU and MU, the rest of the job is very simple. You know, okay? So I was telling you that I have a formula, and that formula is, I call it, if I'm just modeling a building, I call it DAT. DAT. D-double-A-D. DAT. Number one, define, and then assign, analyze, and design. Just see, there are 4 buttons at the top. Define. Can you see define? Yes, the first one.
Yeah.
So I did not include draw in this. The first step is define. I will tell you what is this, define. Then you can include draw, but draw is a basic thing you have to draw. Assign, analyze, and then design. These are the main features of SAP. Okay, let's start with a new model. In the new SAP, you can have many different models, many different types of things, and if you see, it is not for the buildings, it is for the structures. Like we can have beams, very simple type of beam. We can have trusses, we can have frames, we can design slabs, we can design, we can find out the forces, and we can check. Shells, quick bridge. What are these? These are the storage structures like silos, tanks. These are the pipes. These are the specialized structures which are basically, we call them cold trans, and sometimes we have some underground concrete structures. This it is a frame, support frame, and we call this as a bend. This is what I was saying, bend. Bend is an assembly of frame and beam. This is a cable bridge. We have a separate module for a cable bridge, and this is all about the different types of features which we have. For example, the bridge is very advanced, you know, and the beam is the most basic one. You understand? You know, I'm a little bit scared of taking you directly to the most advanced feature. You understand?
Yes.
Because I'm worried that you may not be able to fully understand that how it's working and how the things are going on. And on the same time, I cannot teach you the design of beam and the design of frame itself, because we will not be on our topic, which is basically the bridge modeling. But I will try my best. So what I need special effort from you. You do it by yourself and try to understand. So let's talk, because I have the design of bridge. So let's go for the bridge. You know, for the bridges, I will start the model. I will start the model, but I will not actually complete it, because I will explain you many things, and I'm sure you cannot find all these details in an online video other than this, because this video is prepared especially in the context of bridge engineering course. You know, for example, I know that many of you are feeling difficult to understand many of the terms. Like some of you may have given the wrong answer of abutments. You understand?
Yeah.
But the videos which you can find on the other sources, on the online sources, they are very specialized, and for those people maybe who are actually designing a bridge, sitting in an office. You understand? Okay, let's start. There is a special bridge visit here. The first thing, you have to change the units. You can change the units on this box here. Like there are different types of units: kip inch, kip feet, kilonewton meter, newton millimeter. The most common units in SI system are newton millimeter. But for the bridge modeling, we can use, for example, 20 megapascal. What does it mean? It means 20 newton per millimeter square. 1 newton millimeter square is equal to 1 megapascal. Am I right?
Yes, sir.
So I'm more comfortable with either newton millimeter, newton meter, kilonewton millimeter, and then kilonewton meter. So what you would like? Okay, kilonewton millimeter or meter? Okay, kilonewton millimeter, because in the bridge we have many dimensions in millimeters.
Yeah.
So I think it's better to go for newton millimeter. Okay, let's go for newton millimeter. Okay, next. File. New model. You know, if you directly want to work on a quick bridge, you can start from here. For example, just click on this. Let's do. I click on this, and now it is asking the first information: bridge deck. What type of bridge deck? What is bridge deck?
Include the slab.
It is in. I can also say it is actually the structure above bridge bearing. That was also a question in the quiz.
Yeah.
Yes.
The superstructure. What is a bridge superstructure?
Whatever is above the bearing.
Above the bearing is known as superstructure, not above the ground. Okay? So there is deck. So we have all these things here, like girders and slab, curbs, barriers, all these things are. So for example, here you can, for example, if your bridge has two spans, you can divide them like this. For example, if there are 3 spans, you can add a semicolon and you can add it here. It is written also there. And from here you can select the bridge types. What type of bridge we have? Like concrete T-beam. This is the T-beam which we did. This is a bridge which we did in our problem, you know?
Yes.
The concrete T-beam. This one. Can you see?
Yes.
Concrete flat slab.
About the span bridge.
Yeah.
If it is like the second example, girder bridge, the spans for the interiors and the exteriors, I have to show.
I did not understand your question.
The span I have to mention 1, 2, 3, or more or less, depending upon us.
It is the span, for example, in our case, what we did in our class, that was a simple single span bridge.
But for the girder,
Even for the girder. I'm talking about the girder. The span of girder is equal to the span of bridge.
so I have to mention just only one span.
Yes.
How they mention? You said that you have to put column, comma.
If you have a continuous bridge in which you have 3 spans, you know, I can put 3 spans, but if I give the size of girder equal to the size of span, and I give simply supported conditions to the girder, I'm just repeating my work. It is of no use. Do you understand my point? For example, one bridge deck. Deck is the full assembly of girders and slab. If I put one deck here, another deck same span here, another deck same span here, it is just like 3 simply supported beams. So I'm just increasing my work. I should just design. But if your bridge is a continuous bridge, like here I give you the example next to theme. This is a bridge which they are giving a curve, the biggest span, continuous. You understand? I made a diagram here if you remember. So in that case we can have 3 spans. So we can use this one. But for example, sometimes we have a continuous slab bridge. We have continuous slab bridge. So in that case we can, if we give like this, it will be 2 span continuous slab bridge. But if we define 2 span and over the support we give simply supported condition to the slab. I mean, we divide this bridge slab into 2 separate panels, one slab, another slab, and both our slabs are simply supported. I'm just repeating my work. I'm not doing anything extra, anything new. Okay, you want 1 span or 2 span? One. I'm not starting your problem. I told you I'm just exposing you with the bridge wizard. What is bridge? If you click it OK, oh my god, there's nothing. No, there is. This is your bridge. Yes. So, if you see, you have not defined the width. How much is the width? Did you give anything about the width?
No.
About the curve, about the barrier, about the median, about the overhang, any information?
No.
No. It is just a layout. I mean, it is a layout which is just based upon the span. And if you want to see, you can see the coordinates. For example, the coordinate of this point is, if you put your cursor here, this is a 3D model, you can put a cursor here and you can see the coordinates. What are the coordinates of this point?
0.
X, 0, Y. What is Y? In case of SAP, the X and Y are in plane and Z is the elevation. You can also see it here. I think it's very small, but this is X, this is Y, this is Z. In my computer it's visible, but here I know due to the pixels it's not clear. If I try to maximize, let's see. Now can you see?
Yes.
So X and Y, they are in the plane. They are not in the elevation. Don't think Y is going up. No, Z is going up. Okay? And there is one more thing which I want to tell you. For example, if this is one beam, for example, it is not a beam in fact, the slab, but if there's a beam or if there, let me show you, this is important information, frame section. This is by default frame section here. Add new property. If it is a concrete, it will be rectangular, like this. Yeah, this is what I want to show you, 2 and 3. Can you see 2 and 3?
Yeah.
2, now, x, y are the global coordinate system. You understand?
Yeah.
For example, when I say x, it means in the x direction of the main bridge. Y is mean the perpendicular in the plan view. Z is elevation, but U1, U2, U3. Where is U1?
You want?
Yes, U1 is going out of the plane of the. For example, if this is a column, let's suppose this is a column. So U1 is where?
It's up to you. Coming to you.
If this section is a column, U1 will be where?
Yes.
It will be like this.
Yes.
And U2 and U3. And if it is a beam going like this, so U1 will be. And if this beam is going this way, so the U1 will be. Do you understand what I'm saying? This is important information. For example, if I say this beam cannot move, this beam cannot move. Let me confuse you. we just know movement, M. But in this case, if I apply a load, vertical load, this load will be along which axis?
The two axes.
U2, it will be along 2 axes. And this load will produce, the gravitational load is along 2 axes. This load will produce moment about which axis? For example, the moment will be about which axis?
3 axes.
He's right. If the load is like this, it will produce moment about 3 axes. Can you see?
Yeah.
I'm confusing you. In fact, I'm growing you up. You understand?
Yeah.
So, see, the gravitational load, the bending is like this.
Okay.
And this bending is about 3 axes.
Yeah.
But if the load is along 3, like this, if the load is like this, so the beam will bend like this, or the beam will bend like this.
Like this.
In the horizontal plane.
Horizontal plane.
It will bend, and the moment will be about which axis? 2 axis or 3 axis?
2
Three.
axes.
3 axes.
2 axis.
2 axes.
Now the beam will bend like this. If the load is along 3, simple, remember. Load shear 3, moment 2. Shear 2, moment 3. For the gravitational loads, we have which shear? 2 or 3? 2. And which moment? 3. Good. One thing. You know, when I say my support is fixed support, what does it mean?
It doesn't have movement.
It cannot move.
Yeah.
So it has.
It can take moment.
Yeah.
It means it cannot move U1, it cannot move U2, it cannot move U3. This is mean. Do you understand?
Yeah.
For example, if I clamp, if I say it can move U1 free, U1 free, what does it mean?
It's a pin. Fixed.
What's that? If a beam is horizontal, okay, you know, these things are important. Otherwise, when I make U2 free, you will not understand what I'm doing. You understand? I know that what I'm doing, but you will not understand. So for that, these are the basic features which I think you cannot find anywhere. If you go and Google. Okay, let me show you. Let's talk about a simple beam. I don't want it to do that, but I'm forced to because I don't want to jump directly into the bigger problem. It's like single span beam, one span length 6000. Okay, fine. If you want to give any section, you can define a section. Just click it here. Go to add new property, concrete. Select the material from here, concrete, and then rectangular. And here you can give the size. For example, 400.
200.
Okay, 200. Okay. And also about the material, I'll tell you how you can define the material. This is a simple beam. You can see this is along X. X is this one, Y is this, and Z is vertical. Okay, I have nothing to know about X, Y, and Z because they are the global. What about U1? U1 is along which axis? U1.
X-axis.
X-axis. You're right. Okay, so what I do now, these are the supports. Pin and roller. Okay, if I say this is a hinge support, what does it mean?
That you can move about Y-axis.
It's
Why?
translation. It will not allow movement about any axis.
Yeah.
Not X, not Y. Or not U1, not U2, not U3. And what about roller?
Just one axis.
Which axis will allow movement will be allowed?
Y.
Is it axis? Elevation.
Y axis.
You mean it can move along? For
Z
example, this move, this
Up.
point can go down.
No. No. Yeah.
This point, this can move in this way.
Yeah.
Yes. So it means U1 is allowed. U1 is free, and U2 and U3 it is fixed or clamped. And what about this? U1, U2, U3 all are clamped. This point cannot move in any direction, but it can rotate. It can rotate. Rotation is allowed. There's a difference between translation and rotation. Rotation is, for example, like this. If you just remove this support, and you lift this beam, so it means this beam can rotate about this point. Let's say hinge support. You understand or not?
Yeah.
But if it is a fixed support, can this point rotate?
No.
No. Okay, let's see this. Sine, joint, supports, strengths. Yes. Now, do you understand what does it mean? Let's see about the roller. I click on the roller. Restraint means resistance. Restraint means resistance. So it will allow resistance along only vertical U3. Let's talk about hinge. Can you see?
Yeah.
It will resist against what?
All axis.
All axes. But rotation means it will not resist moment. Rotation means it will not resist. It will allow to move the beam, as I told you. And if you click on the fix,
No rotation.
And either this or no.
but what is the meaning of 1, 2, 3? Do you understand?
Yeah.
That was the point. Okay, if you want to apply a load, I apply a load. Now the both supports are fixed.
Yeah. So.
The supports are changed to fixed. What I do, I select this beam. You want to apply any load or do you want to just check? You want to apply any load? Okay, let's apply. like 5 kilonewton meter. This is a load. Okay, let me analyze. I will explain you all these steps. Don't worry what I'm doing. But I want to show you the forces, the moments and the shear. Now the load I have applied in which direction?
The x-axis.
No.
Vertical load. Plus. Okay. It's a very small model, it will take some time. Done. So now you have the deflected shape. For example, if you want to see the moments, show, display, forces and stresses, frames. Now, if you want to see the bending moment, which moment you will see? The load is gravitational.
About the y-axis.
It is 1, 2, 3. Don't.
It's 3 axis. Yeah, 3 U.
And your load is about which axis?
About the y, 2 axis.
About Z.
So if you want to see the shear, which shear you will see for the gravitational load? 2 or 3?
2.
This is the shear force diagram of a UDA. Do you understand? This is a shear force diagram of a uniformly distributed load, or not? It is like a triangle.
Yeah.
Am I right or not?
Yes.
Okay, I click it here. Forces and stresses. Shear. Like this. And how will be the bending moment?
Like this.
And which bending moment you will see?
About y-axis.
3.
Forget about X, Y, Z. This is what I wanted to tell you.
The 2 axis.
The moment will be about which axis?
3.
If the shear is true, the moment will be the fixed support, so that is why the moment is here like this. There is a negative moment at the support because it is a fixed ended beam. Okay? Do you understand? What is M2? What is M3? Okay, I apply any load along 3 direction. The load is along which axis?
Z.
Z or 1, 2 or 3 which axis?
2.
Any load along 3?
No.
No. Okay, I see. Let's see how will be the shear force. Is there a shear? And what about the moment?
No.
2.
It will be the 2, but there will be any moment or not?
Yeah.
If there is a no load along 3, there will be any moment? No. Nothing. Understand? Okay? Let's go back. So, bridge. Quick bridge visit. Okay, so I go back.